in the midst of the Cold War. Here, the Soviet Union and the United States poised to annihilate each other with nuclear weapons, and it was an extraordinary time.
Of course, we were all given orders, which were supposed to be secret, to come to Washington and to not discuss the reason for those orders with anyone, even our wives.
NASA finally got interested in sending somebody into space. It was such a new thing. It was all very, very secret at that time. We went through a long selection process, and which included physical and psychological and every measurement they knew how to make on the human body, I guess. So when we finally came down on we were finally selected, we were very happy to be there and felt honored to be among the 7 to be selected.
Well, I realized that I had been chosen to be part of the first team. That was the end-all, be-all for me.
The original 7 were, of course, figures that were revered. The engineers who were doing the designs, the launch crews who were doing the day in and day out work, and then the crew shimmying into those little tin cans called capsules that were taking us into the heavens.
The mission was planned to come back and land on the water. And so we did a lot of water training on it too. So what would happen if you had a leak in the spacecraft after you once hit the water, what the impact would be, if you're underwater, could you get out? And training like that tried to train for every possible contingency.
When I got to fly the shuttle, I knew what to expect. I think when John flew his first flight, he didn't know what to expect. And that's a huge difference. When John first launched, he was on a brand new rocket, never been to orbit before. We didn't know how humans would react in zero-G. We didn't know whether they'd be able to eat. Some people said their eyes wouldn't focus. All kinds of crazy stories that John told me that they told him before he launched to expect. He didn't believe any of those, and most of them were not true, but we just didn't know back then.
The day that I finally went, that was the 3rd time I had actually suited up and been on top, been locked in and ready to go. But when you finally get in the thing and you're ready to go, you're very, very busy. People think you're in there contemplating great thoughts, and I think it's more likely you're in there, as I was, double-checking all the instrumentation and talking to the people on the ground crew to make sure that everything was okay for launch.
That countdown for the launch is something you've done time and time and time again, so it was, in a sense, just another day at the office. But this was real, and it caught everybody's attention.
Godspeed, John Glenn. 6, 5, 4, 3, 2, 1, 0. Roger, the clock is operating. We're underway. Loud and clear. Roger, we're programming and roll okay.
Godspeed, John Glenn. I was in the blockhouse when he was, and the last to speak to him before liftoff. Gus and Al had both done that, but they weren't riding on this big, big fuel tank that had the ability to give him more speed than what Al and Gus had had. They didn't have enough to coast all the way around the world. They just had enough to go up a little ways and fall back to Earth.
People look at all this fire and smoke on the ground, and they think you're under huge stress inside. You're not. The thrust is just barely greater than the weight of the spacecraft, so you lift off very gently. And the more the fuel burns out there, the lighter it becomes, and the thrust is still high. So the farther you go up here on this entry into space, the more G's you feel inside.
Roger, 0G, and I feel fine. Capsule is turning around. Oh, that view is tremendous. Roger, turn has started. Roger, capsule turning around, and I could see the booster during turnaround just a couple of 100 yards behind me. It was beautiful. Roger, 7, you have a Go, at least 7 orbits. Roger, understand go for at least 7 orbits.
Everything worked perfectly, and then there was an indication that John's heat shield was loose, which meant that after the 3rd orbit and on the deorbit that he would burn up if it was.
Well, I certainly want to make it a two-way trip and come back, of course.
It's the first thing I actually remember in my whole life is sitting in front of our nice black and white TV on the floor, because I had to get real close because, you know, I was really excited about this, watching the John Glenn flight. And the thing I remember most about it is sitting there worrying about whether or not John Glenn was going to survive when that heat shield was, you know, getting loose.
During re-entry then, instead of jettisoning that retro pack here and getting it off so I had a clean heat shield for re-entry, we left that on so that the heat shield would be held in place until the aerodynamic force of re-entry would tend to hold the heat shield in place. Now that made for an interesting, well, the re-entry was going to be interesting anyway, but it was even more interesting because as I would glance occasionally out the little window, I could see chunks of that retro pack breaking up and coming back by the window.
Our condition is good, but that was a real fireball, boy. I had great chunks of that retro pack breaking off all the way through. Rocking quite a bit. I may still have some of that pack on. I can't damp it either.
And I couldn't be absolutely certain then whether it was the heat shield breaking up or the retro pack. And obviously it was a retro pack or it wouldn't be here today. But anyway, it was that kind of re-entry was the second problem we had in addition to the control system failure.
If you listen to the tapes, it's pretty clear that he knows that there's something going on there. It's not the normal procedure because he knew the procedures really well. He knew that retro pack should have been gone.
Coming out of the blackout period and saying, Houston, this is Friendship 7. And of course the nation went nuts. The world went nuts.
Main chute is on green. Chute is out in reef condition at 10,800 feet and beautiful chute. Chute looks good. On O2 emergency and the chute looks very good.
His odds of not surviving this was about 1 in 6. So it was an extremely high-risk, unknown effort that they were going into, having never done it before.
And it came time for aligning the capsule and the proper attitude for retrofire. There was under-thrust of the rockets themselves, and the result of the intermittently failed horizon scanner meant that the rockets were pointed in the wrong direction. Each one of those failures made me fly a little bit too far, and it all added up to 250 miles. Had a lot of people frightened. I was not frightened by that because, contrary to their lack of knowledge about my location, I knew exactly where I was. I was back on the water where I wanted to be.
We did research. We learned the new things first. And those were, and with a little investment and educated citizenry, away we went with we became a leader in the world in just about a century and a quarter.
It was a total, resounding success. And it was a great, great honor and pleasure to be a part of such a marvelous and successful program.
Good afternoon and welcome to The Ohio State University. My name is Ray Lugo and I'm the director of the NASA Glenn Research Center in Cleveland, Ohio. I would like to thank everyone for taking the time to attend today's NASA Futures Forum here at The Ohio State University. I'm very proud of the partnership we have at the Glenn Research Center with The Ohio State University as we continue to work together to find opportunities to build our relationship and collaborate on the maturation of technology and hopefully the commercialization of those technologies. Today we are here on the 50th anniversary of a great American's first space flight. I was 5 years old when this man went into space. I was home with the mumps. It's a disease that I think has been wiped out in this country. But my mom let me watch Senator Glenn's first flight. And I can remember with anticipation, wondering if he was going to make it back safely. So today we are here looking back on Senator Glenn's first flight, on a career with the hope of unlocking the secrets of innovation that have made this country great. Ohio, aeronautics, space exploration, innovation, all of these words embody the reasons we are here today. It's my pleasure to introduce my boss, himself a member of the astronaut corps, a Marine, and now the NASA administrator, Mr. Charles Bolden.
Ray, thanks very much. Thank you. Thanks a lot. Thanks very much, and I want to thank all of you for coming today because this is it's a very important day. As Ray mentioned, it's the 50th anniversary of John's first flight into space aboard Friendship 7, a very special day for the United States because it established our leadership in space, and it's a leadership that we've not relinquished since. It's really important for us to be here because he is home. And as a native of Ohio here, all of you should be very proud. I'm incredibly honored to be sitting here with him today. I had the opportunity to be with him and Scott Carpenter last week at the Kennedy Space Center. It was just phenomenal. But what we're going to be doing over the next couple of days is we're going to talk about the future. This is a future forum. So we're going to try to talk about vision. We're going to try to take advantage of what John sees for the future based on his experiences of the past. And we want to give you an opportunity to share that with us. Today, America's space program is alive and vital, and it's filled with people like many of you who sit in this audience, or people that you've been seeing on television and you're going to see right now, because we have a special treat that I'm not sure Senator Glenn, he probably is beginning to get a hint that something funny is going on here.
Something's amiss.
But this is an honor for me to be able to introduce Commander Dan Burbank and Flight Engineer Don Pettit live from the International Space Station to have just a chat with the Senator. So, crew, how do you read me?
Charlie, we've got you loud and clear. Welcome aboard the International Space Station.
This is absolutely incredible.
Hey, I'd just like to say that we know you have an awful lot on your plate for the next couple of days, and we're delighted just to get a chance to be here at the opening and to maybe just take a few moments to commemorate Senator Glenn's flight. 50 years ago today, Friendship 7 was orbiting planet Earth, and that helped in a very big way pave the way for America to become a space power and to go to the moon and to do the things that we're doing right now on the International Space Station. And we hope it's also going to help set the stage for us down the road to do even greater things.
Well, Dan and Don, I thank you both very much, but we're going to turn the tables on Senator Glenn right now, if it's okay with you. He's been getting pummeled with questions, and he is probably the biggest champion of the International Space Station. So I'd like to give him an opportunity to kind of pummel you with some questions about life up there, since he's campaigning already for a trip to station. So I want you to wise him up, if you will. So, Senator, if you'd like to pose a couple of questions for him or some comments to them.
You guys are not floating. You got your foot in the strap? You're not. How are you secured there? You got a belt on?
Senator Glenn, it's great to talk with you. Welcome aboard.
Thank you. And he's going to hand my head to me on a platter if I'm not careful with this talk about going to the station. But no, I know you're floating around. That's one of the things you can do up there. And one of the zero-G environment, of course, is why you're up there to begin with, to do the research that can be done there. What are you doing, hanging on? Are you tethered?
And it'll take them a little while.
Yeah.
Actually, I've got one foot underneath a bungee, another foot underneath a handrail. I think Don right now is free floating, and behind us is Andre Kuipers, European Space Agency, Dutch astronaut with us, and Andre's basically free floating as well. It took us a little while to kind of get our space legs, so to speak, but everybody's pretty comfortable managing their orientation in any number of ways.
Do you have any estimate, I don't know whether you know the exact number of research experiments you have on board right now. Do you have any idea of how many are on board?
I knew you was going to give it to Don.
We have well over 100, and they all come with an acronym that you either have no vowels in them, so it makes it really hard to pronounce, or you can't remember what all the words, all the letters stood for in the first place. However, I would like to say that the experiments we have, we've got a whole ensemble of life science experiments that basically probe the gravity knob for life, since it evolved on Earth under constant gravity, and now all of a sudden we can change the magnitude of gravity by a factor of 1,000,000, and we can look at what the effects are on living organisms, including human beings, under that. And then we have physical science experiments, growing crystals, looking at surface tension and other related phenomenon that gravity masks, and then combustion experiments. I did a whole suite of combustion experiments this morning. It was really fascinating.
Yeah, are you able to keep combustion going with less fuel required? I know that was one of the things that they came up on Columbia before it was destroyed.
You know, that I don't know. I do know that you have to fan the flames if you want to keep them going up here. We're looking at forced convection, and the fuel that I was looking at this morning with help from folks from NASA Glenn was ethylene. We're looking at 20% ethylene and burning that in air under forced convection, and looking at when you get separation of the flame from the fixture that holds it.
That's very interesting. I've thought those energy experiments that were started on Columbia, I thought were fascinating, and they had a lot of important future maybe right here on Earth. I don't know whether people here in the audience right here today realize, but you know, a candle has a flame goes up because the air is heated and the convection goes up and pulls the flame up. But in space, when something burns, it just collects in a big cloud around it. So you get a whole different set of burning and combustion principles than anything you can't duplicate that here on Earth. And there were some of the indications were that we might be able to have combustion with far less use of fuel on some of the Columbia experiments, and that's what you're continuing that right now, I guess. Is that correct?
Yes, Senator Glenn, and I find it philosophically interesting that civilization started with fire and learning how to use fire, and it's served us well for millennia, and we are slowly refining our understanding of what fire is, because fire will work whether or not you really understand all the details of the chemistry. Yeah. And what we're doing now is, again, using a reduced gravity environment, which changes the dynamics of combustion, so that we can dissect even more detail out from how fire works, which is obviously a needed element even as we leave planet Earth and go off into the go away from the planet.
Yeah. Hey, Dan, we've got a number of very young students here with us, and I know I was watching you earlier. It may have been a replay, but the first handshake between a humanoid robot and a human in space. Can you talk a little bit about R2 and whether R2 is behaving or is developing a mind of its own already?
Yeah, we were talking about that. There's we wanted to make sure that all three laws of robotics had been incorporated. But in all seriousness, a couple of days ago we had Robonaut R2 out here in the lab, and we were basically doing some checkouts on it. And at this stage, really, it's a technology development program. And the idea is that all the interfaces, all the things that we have on space station that we interact with, are all designed for humans, for human hands, for human arm length, for the parallax that human eyes provide, and essentially Robonaut has the same functionality, the same capability as far as interacting with hardware. So it affords down the road a very good opportunity to take the tasks that are routine and perhaps some of the tasks that might be more dangerous for crew members to do, and basically help offload us and share those tasks with an anthropoid robot. And ultimately, I think it also has a lot of promise for doing spacewalks, and those can be, of course, one of the most dangerous things we do in space.
Now, put the three of you guys on the spot, because I don't think the senator's ever been asked a question from space. So how about if the three of you put your heads together, play like you're a newsman, and give us a question that's really rough for him.
Thanks a lot.
And Annie's sweating beads under.
So, Senator Glenn, did you ever really find out what the fireflies were on your first orbit?
Yeah, we did. I think Scott Carpenter on the second flight was able to hit the side of the spacecraft, the capsule, and send the whole shower of them out. And the scientists working on this, they could relate them to the water dripping out through the heat exchanger, which was a controlled thing. And then they just collected in a large cloud around the spacecraft. The one thing I don't know that scientists have ever figured out yet is why the glowing luminous color. Water particles will go out and freeze, and then the light comes from the sun and through the Earth's atmosphere and back out to the spacecraft again. And what changes the light in that, what is refracted there, so that when it hit these frozen particles, they glow sort of a glowing luminous color. And I don't know that we ever figured that one out. If we do, I don't know what the answer was on it, but they weren't anything that was going to do me any harm, so I wasn't too concerned about them.
If you guys had an opportunity to bring this, since he's bugging me all the time, if you had an opportunity to bring him up for, say, a couple of months stint on station, okay, Annie, I'm just kidding. Which experiment that you're doing now would you most like to hand off to him, and why?
One thing that we didn't talk about already, which I think is a key thing that we're doing on board Space Station right now. We do a lot of the life sciences and physical sciences, but one thing that we're doing on station really, I think, falls in the category of engineering development, technology development. And I think this is some of the key things that will help us leave low Earth orbit, go on to the moon, asteroids, and on to Mars. And I think one of the things that we learn an awful lot about every day that we get a chance to interact with it is the regenerative environmental control system that we have here. So I think, based on his experience, the senator's experience, it would be really neat, very interesting to get a chance to work with him on the systems that we have to provide that capability. If we spend so much time sometimes focused on the details of those tasks, it would be really good to have a big picture look on about that, and also from somebody who has thought about leaving low Earth orbit from the perspective of lawmakers in our government.
And really what Dan meant to say was, when he was talking about the regenerative life support system, that's a fancy word for our toilet. And so he wants to put Senator Glenn busy fixing the plumbing up here.
That's exactly what I thought I was going to get assigned to. Thank you.
And I think now that Don's pointed it out, I may find myself replaced outright with the senator.
You got anything else for the crew there?
One other question. Do you have any plant growth studies on board right now? Because those are fascinating, too.
Well, just as a little investigation on the side, I've been growing a few plants. And as Senator Glenn, I was able to get a zucchini plant to bloom, and it bloomed on Valentine's Day, and I had a special conference with my wife, and I presented her with a zucchini flower. I mean, it's not a rose, it's not a lily, it's not a carnation. It was a zucchini blossom, and she could only see it on the downlink video. But I did pick that blossom, and I stuck it in our World Atlas. I'm pressing it between pages, and I'm going to bring that home and give it to her.
That's good. Great.
Everybody went, oh. Hey, we're here for a future forum. So for the next...
One thing.
Go ahead.
Just so everybody here, I wonder about how far around the Earth they've traveled just while we've been talking to them. Probably a fourth of the distance around the Earth, just in the time we've been talking.
Either of you watching the map?
No, they're not, probably.
And I'd say that's about right. Yeah, so it's been basically a fourth of the way around the Earth. So
wow.
In the order of about 10,000 kilometers thereabouts.
Yeah.
Quick question for you. As I was saying, we're here for a future forum for the next day and a half. You know, just from what you've seen so far, what would you like to be a topic that this group considers in terms of where should we be 20 years from now or 30 years from now, based on what you've seen and experienced this time? And you know, I know it's your second time up there, Don.
Well, I think there's a lot of aspects to that. And I think one thing that, one of the biggest challenges that we have on board Space Station that we've probably had in any spacecraft before, and it's something that with the Space Shuttle, we really didn't have this case. In the Space Shuttle, every time we flew it, we returned it to the factory in essence. We returned it to the people who knew how to build it. On board Space Station right now, astronauts have to be essentially jacks of all trade. We need to be able to fix anything and everything that happens. We need to essentially be professional technicians on a par with the people that for decades have put their heart and soul into taking care of incredibly complicated and exotic vehicles in the form of the Space Shuttle. If we leave low Earth orbit, one of the key things, one of the most important things I think we need to have is we need to have the capability to essentially cut the umbilical, to be able to maintain spacecraft to the degree that if something breaks, you can replace a part outright. You need to be able to fabricate a part. You cannot bring with you all the pieces and parts that you might anticipate that might break over the course of a couple of year mission. So one of the key technologies, and it's something that I think is a unique need for spaceflight, is to find some way to be able to fabricate parts that we can replace, and to be able to do those things, obviously in conjunction with the ground, that's going to help you, talk you through those things remotely. But the fabrication part and the repair capability is one of the biggest challenges I think we have.
And then I think that one aspect of going away from Earth that we need to think hard about is, do we take everything with us on the mission from planet Earth? Do we lift everything we need from Earth's gravity well? Or do we figure out how to take materials from elsewhere and use them to enable missions? And this all boils down to what I refer to as the tyranny of the rocket equation, and what the engineering implications are to the rocket equation for the design of our rockets that we launch from the surface of Earth, and the implications of how much payload can any given rocket take up, and what do you use for that payload. And when you look at building bases elsewhere, it's going to take hundreds of tons of material to build and maintain a base, and how do we get those hundreds of tons of material up into space? And I think we need to do some serious thinking about the rocket equation, maybe alternate ways to try to get things into space that don't necessarily use the rocket equation, and possibly think about getting materials, brute force and ignorance materials that we need by the multi-ton from other than planet Earth.
Don, you let me ask you one. Go ahead, Andres.
Let me ask you one. Go ahead, Andres.
Yes, as an international representative of the international partner, I think it would be nice to add the question to the future forum, how the future is going to be in the sense of international cooperation. We work together with a lot of partners here now, and I'm curious what the forum thinks about going beyond Earth orbit as an international effort.
Fantastic. I appreciate that because I'm thinking about it. We don't have a lot of time left, but let me ask you all to just tell all of us, if you can, you know, we're getting ready to send the first private spacecraft up to get ready to bring you supplies. What type of training are you doing to stay ready there on board in case, you know, the Dragon or Cygnus happens to get there during your watch?
That's a great question, and it's really important for us to be able to maintain currency, and that comes right down to the piloting skills of being able to do a robotics capture of a free-flying vehicle. And should SpaceX Dragon make it here during my watch, and I hope it does, the way we're keeping ourselves current is by practicing using a program called Robot, and that is essentially a robotics simulator that uses some of the tools we already have developed at Johnson Space Center by folks that work in the virtual reality lab there. And those tools allow us to essentially simulate the environment right down to the dynamics of how the space station robotic arm works, the dynamics of the motion control system of Dragon, and very high fidelity graphics. And it allows us to essentially go through all of the crew coordination skills and the monkey skills of flying the arm right up to capture. And we can do it multiple times. In addition to that, we can also do dry run captures using the real space station robotic arm to grapple fixtures on space station. That's something we have done a couple of weeks ago.
Hey, I want to thank you guys. I know it's, you know, you're really busy up there. I appreciate you taking time to just help us entertain this crowd here, and I'm going to turn it over to Senator Glenn for a final farewell.
Well, this is really a great surprise this morning. I didn't know I was going to have the honor of talking to you guys up there, and I just was sitting here thinking a minute ago about how technology has gone ahead so rapidly in the space age, because here we are watching high-definition television here, and you guys coming through perfectly. Back in the Mercury days, we had to go over each station on the ground apart and couldn't even keep communications. Now we have the TDRS Technical Data Relay satellite that you relay through, so you have constant communication around the Earth. It's just amazing that we can sit here and talk to you back and forth. So thank you very much for helping kick off our forum. It's really great. Congratulations to all of you. Thank you.
And from and I guess from the Ohio State University, I'm learning.
You're
okay.
learning.
The home of the Buckeyes. We're going to pass it back to Houston and let you guys go about your work. But thanks again. This has just been incredible for us. Thanks so much.
Thank you so much. It's been an honor and a pleasure for us as well.
That's amazing.
It is.
Yeah.
Fantastic.
Okay. Something my mom taught me a while back was never follow an act like that. It was great. I tell you, the ability to have a conversation with people living and working in space, again, something I would have never thought of when I was a 5-year-old boy watching Senator Glenn and his mission. So, Senator Glenn, the surprises aren't over yet. You've been recognized by your peers in the astronaut corps, and we have some special messages from your peers in the United States Senate. They wanted to be here today, but they unable to attend, but they wanted you to know how much you meant to them.
Hi, I'm U.S. Senator Sherrod Brown. Thank you to everyone at Ohio State and at NASA for organizing today's forum on the future of innovation and space exploration and celebrating John Glenn's historic Friendship 7 voyage. Special thank you to NASA Administrator Charles Bolden, Deputy Administrator Lori Garver, NASA Glenn Center Director Ray Lugo, and to all of the other NASA officials for being here today. Administrator Bolden has heard me say many times that Ohio is our nation's aerospace state. We're not just the birthplace of aviation and aerospace, we're its future as well. And that has to do with so many of you who are here today. I wish I could join you. Connie and I were fortunate to spend time with John and Annie on Sunday night. It goes without saying, as many of you understand, that time spent with them is always special. John will roll his eyes if I start retelling stories he's heard over and over, so I'll spare him. But last week it was an honor to introduce a bipartisan Senate resolution that passed, of course, unanimously even in this Senate, celebrating John's historic flight 50 years ago. John wrote of the original Mercury 7 astronauts, "The world was at the door of a new age. We were the people who had been chosen to take the first steps across the threshold." In 50 years, NASA and our nation have come a long way, crossing threshold after threshold through triumph and setback. But where we go in the next 50 years or the next 100 depends on what we do today. That's why this forum hosted by NASA and OSU is so very important. Investments in science and education are critical to the future of our nation's space innovation and exploration. They're also crucial to and critical to our nation's economic competitiveness and to our national security and to our environment. But how do we best leverage and link investments in science and education? First, we must continue leveraging crucial research and development investments even as we rebuild our economy and balance our budgets. Public investments, NIH, National Science Foundation, NASA, and the R&D awards and grants they offer are surely a cornerstone of what we do best as a nation. John spent so much of his time in the Senate working on those investments. We see those investments leveraged through public-private partnerships with OSU, with Battelle, with Ohio's Edison Network. We see it across industries from aerospace and defense to medical research and advanced manufacturing. NASA Glenn is working with the automotive industry to share technologies they've developed for spaceflight that will now revolutionize the next generation of vehicles. It's partnering with the Air Force Research Lab at Wright-Patt to develop cutting-edge space technology demonstration projects. Take a look at NASA's annual Spin-Offs publication. It's clear that many of today's household products and technologies were made possible because of investments only our government could make. Second, John couldn't have orbited the Earth without NASA's world-class workforce. He'd be the first to say so. NASA Glenn was placed in Cleveland because of its proximity to a strong industrial manufacturing base. We must continue to strengthen our workforce in our manufacturing supply chain if we're going to strengthen efforts in space innovation and exploration. Ohio has state-of-the-art research facilities and universities that are leaders in aerospace R&D and educating our future engineers and scientists. NASA Glenn and Battelle have won a combined 354 of the storied RD 100 awards. These awards are a mark of excellence known across the research community and are a testament to the innovation found right here in our state. Today, our nation still faces a gap between the needs of emerging science-based industries and the skills of our workforce. I've worked with Ohio's network of universities and community colleges to introduce legislation that would help local industries partner with local communities and local labor unions to fill jobs in sector-based industries. Our future space exploration and our future economic competitiveness depend on American workers equipped with the skills to outcompete, to out-innovate, to out-manufacture the rest of the world. It depends on strengthening Ohio's storied aerospace manufacturing supply chain to ensure that our own aerospace manufacturing, R&D, and innovation stays right in Ohio. Investing, building a workforce, strengthening our manufacturing supply chain are all critical to our future space innovation and exploration and to our economy. And so too is recognizing our history as a nation and a state that instill a sense of pride and duty in crossing thresholds of discovery. One of the first press conferences of the Mercury 7 astronauts, our friend John Glenn said, "This whole project stands with us now like the Wright brothers stood at Kitty Hawk. I think we stand on the verge of something as big and expansive as that was 50 years ago." And now it's been 50 years since then. John, congratulations. Annie, congratulations on the 50th anniversary of your flight. and your support and your time, your years and years together. Thanks to everyone at the Future Forum for pushing all of us to think big about science and innovation and progress, and to pursue those dreams beyond what we may think some days are possible. Thank you all.
Hi, I'm U.S. Senator Rob Portman. I'd like to welcome all of you to NASA's 2012 Future Forum here in Columbus. I really wish I could be with you in person, but I'm glad I could join you by video and honored to have the opportunity to pay tribute to the man of the hour, my friend John Glenn, and to say a few words on the future of American technology and aviation achievement. Thanks to everyone at NASA and The Ohio State University for bringing together such a distinguished group of leaders, scientists, engineers, and education professionals for today's event. A special shout out to Gordon Gee, Charles Bolden, Lori Garver, Leland Melvin, and Dr. John Grunsfeld, who I'm sure will have a lot to say on the importance of further advancing innovation and technology during their panel discussion. As everyone here is well aware, NASA, through the Glenn Research Center at Lewis Field in Cleveland, is a treasure for our state. Every year, the center stimulates millions of dollars of economic activity within our borders and partners with private companies and public universities, like Ohio State, to conduct state-of-the-art research and development. Events like the one here today at The Ohio State University only serve to strengthen the more than 60-year partnership between Ohio and NASA. The state of Ohio is known as the birthplace of aviation and a leader in space exploration. Give the Wright brothers credit for launching us into the air, but John Glenn credit for taking us into space. 50 years ago, on February 20th, 1962, John Glenn became the first American to orbit the Earth when he piloted the capsule Friendship 7. While in orbit, John performed a series of breakthrough experiments, overcame severe problems during re-entry, and completed the mission by landing the spacecraft safely in the Atlantic Ocean. I've talked to John about what it was like being in that capsule, as many of you probably have. All I can say is that I know he wishes he had had the 50 years of research, innovation, and experience represented in this room today to make that flight more comfortable and safer. On top of being a national hero as an astronaut, John Glenn gave 23 years of distinguished service as an aviator in the United States Marine Corps and 4 terms to his state and country as Ohio's United States Senator. John Glenn's tremendous achievements have paved the way for so many others. He continues to push for the United States to be a global leader in science, technology, education, military service, and public service. One of his achievements, the John Glenn School of Public Affairs at The Ohio State University, prepares bright young minds for public service. I've had the privilege of co-teaching 4 courses at the Glenn School and have the honor of serving on its board of advisors, along with Senator Glenn and his wife and partner in all things, the amazing Annie Glenn. It's in John's footsteps that we must continue to ensure America remains at the forefront of aerospace and scientific advancements. Some of you in this room will be responsible for our nation's next wave of breakthrough technology, and I look forward to working with you and supporting you in the years to come. On her 90th birthday, my grandmother wore a sweatshirt that said, "I'm celebrating my 50th birthday." On the back it said, "This sweatshirt is 40 years old." In that spirit, happy 50th, John, and Godspeed to all of you in your important work.
Good. Thank you to Senator Brown and Senator Portman. So, we're here to our first panel. It's titled, Learning from the Past to Innovate for the Future. The panel members will provide a retrospective on Senator Glenn's amazing career and will also a preview to the bright future in human exploration. At this time, I would like to introduce our panel moderator, Dr. Carolyn Whitaker, Vice President for Research for The Ohio State University, and a friend of mine took me to my first Buckeyes game, I think it was a year ago. Purdue took a beating from the Buckeyes. Hopefully that'll continue in the future. Dr. Whitaker.
Ray, thank you. You performed very well during your first Buckeye game. I'd like to thank you, Ray, and the NASA officials for the inspiring link up with the International Space Station. I think it's a real thrill for the people in the audience, the students, staff, faculty, and administrators and guests in the audience to witness such an unprecedented connection. We're honored to be here today with these distinguished panelists, and I'd like to first introduce them and then come back to say just a couple of things about Senator Glenn and the importance of today. On the far end is Vijay Gattapalli. Vijay, can you wave to the crowd? Vijay is a PhD candidate at Ohio State in the Department of Electrical and Computer Engineering. He's working on autonomous vehicles, very relevant to the space program. Vijay also serves as the president of the Council of Graduate Students on campus, representing the voice of more than 10,000 graduate students. Next is Dr. Serena Anand, who is an engineer as well as a physician, board certified in internal medicine and aerospace medicine. She is a member of the 20th class of NASA astronauts and recently graduated from astronaut candidate training. On the far end is Dr. John Grunsfeld, who is the Associate Administrator for the Science Mission Directorate at NASA headquarters in Washington. Dr. Grunsfeld oversees the science program, including the deployment of Earth-observing platforms, balloon investigations, astrophysics missions, and deep space planetary missions. He managed the science program for the Hubble Space Telescope. He is himself an astronaut and has been on 5 shuttle missions, largely related to the Hubble telescope. Dr. Charles Bolden, Honorable Charles Bolden, I gave you the doctor there, the 12th administrator for NASA, who began his role in July 2009. As head, he leads the entire NASA enterprise, ensuring that both financial and scientific goals are met. Mr. Bolden spent 24 years in the Marine Corps, including 14 years in the NASA Astronaut Office. He flew 4 space shuttle missions, 2 of them as the commander. In that role, he deployed the Hubble Space Telescope and participated in the first joint U.S.-Russian shuttle missions. Next, and in the center, who probably needs not much in the way of introduction, is the Honorable Senator John Glenn. He is a native Ohioan who attended Muskingum College. He served as a Marine pilot in World War II and as an Air Force exchange pilot in the Korean War. He was selected to be one of only 7 NASA Mercury astronauts. 50 years ago today, he made instant history as the first American to orbit the Earth, completing 3 orbits during just under 5 hours. He was elected to the U.S. Senate in 1975 and served 4 consecutive terms as the senator from Ohio. He made history again when he returned to space in 1998 as a member of the NASA shuttle STS-95 Discovery mission. That year, he partnered with OSU to establish the John Glenn School of Public Affairs. That school today offers full-service programs, undergraduate, master's, and doctoral programs in public affairs. Senator Glenn has often said that our democracy depends on the participation of everybody. And he truly embodies the motto of the school, which says, inspire citizenship, develop leadership. Senator Glenn himself is center stage today and tonight as we celebrate the 50th anniversary of his orbit of the Earth. He was not the first man in space, nor the second. Those honors had gone to 2 other Mercury astronauts a year earlier. But what made his flight extraordinary was that he was the first American to orbit the Earth. That, in essence, put the United States back in the space race against the Soviet Union. John Glenn was and is the face of the space program, a daring jet pilot who brought the U.S. glory in the quest to top the Soviets. For his efforts in 1962, he addressed a joint session of Congress, and he and the other Mercury astronauts were honored in a ticker tape parade in New York City. And you'll see some remnants of that ticker tape parade in an exhibit over in the Thompson Library. When he returned to space in 1998, his star power brought renewed attention to the space program. So we're here today to talk about that space program and about its future. So to start with, I'd like to turn the floor over to Senator Glenn for some of his comments.
Well, thank you very much for that generous introduction. I appreciate it very much. Annie, I hope you were watching the station up there. Doesn't that look like you'd like to see me go up there? That was really something. I appreciate, Charlie, all your people setting that up today. That was a real surprise. I didn't know that was coming. But it's great to talk to the guys up there, and they're doing such great work. Big picture philosophical approach to things a minute. We have a new country here, the United States of America. It's got a couple million people along the eastern seaboard, and in just about 125 years it expanded not only geographically a little bit, but what elements made that country a leader in the world in just about 125 years? And I'd submit there are two things. One was education for all of our people. It wasn't just something that was for the kids from the castle or the rich kids, it was for everyone. We wound up with that with the most educated citizenry, particularly in the area of math and science and technology that formerly had been the province of only a very comparatively few people. And then the second element that I would say is key toward that expansion was basic fundamental research. We learned the new things first. And we with an educated citizenry, a little investment, wow, new whole businesses and industries, and whether it was better ways of making steel or automobiles or whatever it was, or eventually computers and so on. We led the world in innovation and technology, and that's where the new and good jobs came from and spread from here on around the world. And if we ever lose that kind of lead, then we lose world leadership. I truly believe that. Now that's where I think some of the NASA is in a difficult position today, quite frankly. It's sort of a hold your breath period for NASA as to what's going to happen, because the only way we go into space now, as has already been mentioned here today, was to go over to the Soviet Union or go over to Russia, and we pay them, we buy seats for them to put our people into space on the Soyuz. And this comes at a real price, because what we cannot do then is send our people up with all the equipment and everything they need to our own space station, which was developed just to do this kind of continuing research, the research in this new environment of space. And it's something we have the opportunity for, and I hold my breath almost every day to think that if something might happen on the Soyuz spacecraft, that we would not be able to send our people back and forth to the station, and it would terminate our human flight until what Charlie is working on very hard right now every day is trying to get our new transportation system in both boosters and spacecraft ready to go into space and transport our own people back and forth to the International Space Station. How did we get in such a position as that? Well, I don't want to name names particularly, but in the last administration, not this one, the decision was made that we're going to the moon and on to Mars, but no more budget to do that. If you can contemplate that, you assign a mission like that, no more budget. The money was to come from existing NASA budget, and to do that, it meant cutting out all the shuttle flights, which are expensive. They ran about $400 million per flight, I think was a general average, if I've told correctly. About $400 million per flight. So they were expensive, but it was our only means of getting back and forth to our space station and do the basic research that I think is so fundamental in the competitive world in which we live today. So I think that was a very, very, very poor decision. I don't know who advised the president to make that decision, but in the last administration, that was where the decision was made. Charlie and his people then come in this administration, and they inherit that, and have been working to make sure that just as much as they possibly can, that we keep a good system of going back and forth to the space station so we can do this basic research. I've always thought there are two kinds of research. One is just exploration. That's what too many of the press people write about all the time. Exploration, where are we going, where are we going? That's it. There are two kinds to me. Macro exploration, that's what that is. How far can you go, keep people alive, bring them back, new experience for human beings. The other is micro research. It's once you get to that point, once you get to the ability to travel to a new spot, as we have in Earth orbit, then what kind of research can you do that will benefit people right here on Earth? And I think what the guys say, they got 100 and some things up there they're working on the station right now. Charlie had a whole, on the flights he made on the shuttle, had a whole bunch. On the last flight I was on the shuttle in '98, we had 83 research projects on that one flight. Columbia, before its demise, had 90. So that's the objective of the program, is to get the basic research. It's not just to do stunts for the United States, to say, we're wave our finger in the air, we're number one. Stunts here, we kept a man in the vehicle alive out here and back for so many miles. But that enables you to do new research in this area of space, in which you learn new things that are benefit to people right here on Earth. And that, to me, is the dual purpose of the program, not only to go farther but to out into space, but also to do things that benefit people right here. And that lays a basis for people's knowledge that the space program is well worthwhile for whatever we do in the future. And I think I just went well over my 5 minutes.
It's your time.
Mr. Bolden?
Well, let me start. Dr. Whitaker asked me to, she suggested that I might say how I happen to be here. Not as the NASA, well, yeah, as the NASA administrator, but how did I get into the space program? And because I see there are a number of young kids here who, what's your name, by the way? Travis? Is that right? And what's her name? Sarah and Travis. When I was the age of, and I don't know how old they are, but I can guarantee you, when I was the age of Sarah and Travis, I did not have a clue about going to space. I didn't dream of it. When I was in high school, when I sat on my campus at the U.S. Naval Academy, going to space was not something in my plans. It was something that came to me opportunistically, if you will, because I met people who had been selected in NASA's first group of astronauts who asked me if I was going to apply, and I said, not on your life. And it was the late, great Dr. Ron McNair, who was in the first group selected. He and I had grown up in South Carolina, same time, did not know each other, both African American. He had always dreamed of going to space and had pursued his dream by applying. I had chickened out. And he said, why are you not going to apply? I said, well, they'll never pick me. And he said, that's the dumbest thing I ever heard. He said, how do you know if you don't ask? So he kind of goaded me into applying, and I did, and I got selected. So that's how I got here. But now that I'm here, what are we doing? And let me give you some basic groundwork on which you can build your questions and the commentary as we go through this day and a half. The senator mentioned where we are. I want to talk about where we're going. The budget that the president just put forward for NASA is $17.7 billion. Now that's not what we had envisioned at this time, but that's pretty good. $17.7 billion represents essentially a flat budget from last year, and in today's world, flat is up. If you own something like a house and you don't lose on it, that's good. So flat is up. So first of all, that's a good news story. The second story is that the president and the Congress over the last 2 years agreed on 3 priorities for NASA. They said, enough chasing everything. Here are the 3 things we really want you to focus on, and then use everything else to build upon that. First and foremost in the area of science was, let's finish the James Webb Space Telescope. Let's get it to orbit and bring us a plan so that we can ensure that we'll do that. John Grunsfeld's been working on that and continues to do so. So we have a plan in place, a budget in place that will support getting James Webb to orbit in 2018. Second thing is the International Space Station, which is a real personal favorite of Senator Glenn's, and I know he's going to talk more and more and more about it. But we have to sustain the International Space Station. We have agreed with our international partners that we'll keep it at least through 2020. We've now certified it for flight through many more years after 2020. But we've got to have a capability of getting American astronauts and cargo to the International Space Station. So we're in the process right now of trying to facilitate the success of private industry, the same people that have built our spacecraft all along, but enabling them to produce the vehicles to take American crews and cargo to the International Space Station. And you're going to see sometime this spring and summer the very first demonstration by a private company, hopefully 2 private companies, to get cargo to the International Space Station. by way of SpaceX with their Dragon module, and then by Orbital Sciences with Cygnus. So that's doing that is essential to supporting the International Space Station. The third priority is the exploration that the Senator mentioned about, moving on beyond low Earth orbit. And we're doing that by trying to design and build a heavy lift launch vehicle and a multi-purpose crew vehicle. Those things are budgeted for, and they're planned out. In the area of science and technology, we're trying to come up with new technologies that will get us from point A to point B faster. So new in-space propulsion, storage and transfer techniques for cryogenic material that we need for fuel. You heard Don Pettit say, we can't continue to take everything from the planet. We've got to be able to place some, pre-position some there, and then be able to get to it when we need it. Being able to go to a place like the moon or to Mars, and whether we do it robotically or with humans, extract materials that you need from the surface of that particular planet so that you can use it. The only positive balance of trade in America today is aviation. We lead the world in aviation technology and technology development, and that's because a lot of the work that goes on at the Glenn Research Center, at Ames Research Center out in Mountain View, California, at Langley Research Center in Virginia. We are continuing to do that, and so that we can continue to lead in aeronautics. So that's what we're about. We're looking at a new way to, John has been challenged to put together a more frugal way for us to do our robotic Mars exploration that's going to be the precursor for us taking humans there. So kind of very quick run through the overview of where we're going, but I hope we'll have an opportunity to talk about it and get your ideas on maybe things we should do better or can do better.
Thank you, Mr. Bolden. Dr. Grunsfeld?
Well, thank you very much. Wonderful to be here, and of course with the great Senator Glenn. Unlike Charlie Bolden, I actually did imagine when I was growing up and I was Sarah's age that I would someday go to space. In fact, so much so, not only because I was inspired by the Mercury, Gemini, and Apollo astronauts, and later the first shuttle class of astronauts, but at the pace we were going, I just assumed that if I grew up to be a scientist and an astrophysicist, that all scientists and astrophysicists would work in space in the same way that they went to mountaintops. The next great frontier would be space. And I'm just so privileged to have actually made it that step because not every current astronomer gets to go to space and work on telescopes, but perhaps Sarah's generation and Travis's generation and other young folks in the audience, that's what we're trying to make possible. Very early on in the space program, it was recognized that science would play an important role. In fact, it was due to folks like Senator Glenn and others, the second administrator of NASA, James Webb, who fought to make sure that science would become a constant part of the NASA program, and it has been ever since. That's one of the reasons we're naming the James Webb Space Telescope after that second administrator, is because he did put the science into NASA. And the James Webb Space Telescope, launching in October 2018, will be the Hubble 2.0 of astronomy. It's going to be phenomenal. So I hope you all pay attention to that when we get there. But we have a lot going on. Of course, we still have the Hubble Space Telescope in orbit, producing discoveries just about every day. But looking towards a future that we haven't seen yet, hopefully all of you, as you came in, stopped and looked at the NASA exhibit. And there was a very large rover there. That's the Mars Science Laboratory, the Curiosity rover. It's on its way to Mars right now. And I may seem calm at the moment, but August 5th, Pacific time, August 6th here in Ohio, middle of the night, the Curiosity rover is going to enter the Mars atmosphere, slow down just a little bit, deploy a parachute, and then fire some rockets to come to a stop above the planet Mars, where a sky crane will lower down that very large 1-ton rover to the surface. And then the fantastic science is going to begin. We're going to go to a place that we think is going to be very exciting, and I'm sure it will be, Gale Crater on Mars. And the things that we're going to learn about with all the science experiments on the rover and the wonderful video and photography that we're going to get as it roves around Gale Crater, I think is just going to blow us all away. So we have that to look forward to. We have a MAVEN experiment that's going to study Mars's atmosphere that's in production and will go out next year. And we have an experiment that was just selected by NASA, OSIRIS-REx, that's going to go out to an asteroid and bring a piece back later in the decade. So that's pretty cool. And of course, we're continuing. We have a whole fleet of satellites orbiting along with Dan Burbank and Don Pennant and Andre Kuiper's looking at planet Earth and also studying the sun. Of course, as much as I like Mars, Earth is still my favorite planet. I have a particular attachment to it, and the sun is my favorite star. And we're trying to understand still how our closest star works. You often ask people, what's the closest star, and they think, Proxima Centauri. But in fact, we live very close to a very large star that keeps us warm day and night, and is very important to us. So NASA science is, I think, kind of the backbone of NASA. As we go out and explore, it continues to provide both robotic and human returns here back on planet Earth. And I look forward to a very bright future for NASA science.
Thank you, Dr. Grunsfeld. Dr. Anand?
Well, it's also an honor to be here amongst all the people you see here on the stage. Again, I'm the rookie here on this stage. All these gentlemen have flown many, many times in space, and I have not yet, but I really want to. So that's what our class is working towards. But like Dr. Grunsfeld, I wanted to work for NASA since I was about that tall. And I received a Bachelor's of Science in Electrical Engineering and then kind of veered off towards medical school and learned about aerospace medicine and ended up being a flight surgeon for NASA. As part of that, I went to Russia and took care of a lot of crews in training out there. So I was able to spend many months watching them as they lived and worked and trained for space station missions. And that kind of sealed the deal for me. So I took a chance and threw my hat in the ring. And again, I've been very honored to be in the Corps ever since. I wanted to talk to you a little bit about how our class's training is really pretty different from many of the classes before us. When we applied for the Corps, we knew there was no more shuttle. We knew that our mission, our primary mission, would be 6-month stays on board the International Space Station. So when our training began, we focused on International Space Station systems, robotics, Russian language training, and also spacewalk training, or EVA training. And as you heard Commander Burbank say up on board, we can't bring the space station back down to Earth to make repairs. We have to do those repairs ourselves. So in the past, when astronauts would kind of be funneled into one area or another and would either perform robotics on a shuttle flight or do a spacewalk on a shuttle flight, everybody that flies on board the International Space Station has to pretty much be a jack of all trades and do everything, because you don't know when something's going to break. You don't know if you're going to have to go out the airlock and fix something during your stay. So it changes the game a little bit. Makes it tougher, I think. We have to make sure everybody stays current. So we've got astronauts spending all kinds of time inside our special pool where we do spacewalk training, doing robotics training. I spent a lot of time in the medical branch there in the office since I am a physician. And so I will say that the neat part with our class is, remember, when we came in, shuttle was finishing a very long, successful career, and station was near assembly complete. So everything's already been built. Now, we're working with the commercial companies and with folks, again, in the government, building the Orion, the MPCV, and helping them design their vehicles. And nothing is more exciting than that. So a typical day for me, I'll work on space station concerns or issues that deal with crew health and safety, and then I go to another meeting where we talk about designing a suit or the environmental control system for some of these commercial companies, helping them through that. And nothing is better than helping to design a vehicle that you might get the chance to fly on. It provides a lot of hope, and it really inspires. So things are very, very busy right now, and you all know that NASA is undergoing another selection, and we had a huge number of applications, I think the second largest in selection history, which is great news because we need all the help we can get right now. So can't wait for those new folks to come on. There's a lot of work to be done. I think in the future, and people talk about 5 or 7 or 10 years being a long way off. It's not that far off in the space business. And I think the 3 things that we're really going to see: continued successful operations and science being performed on board the International Space Station. I think you're going to see commercial companies go to and from the space station carrying astronauts. And I think we're going to see Orion, the MPCV, take astronauts beyond low Earth orbit. So we may be in a period of transition and may be a little bit uncertain, but our class is excited, as is the rest of the Corps. So,
thank you very much. BJ?
Thank you, Dr. Whitaker. Good afternoon to my fellow panelists and the audience. It truly is an honor to be on stage with Senator John Glenn, Dr. Charlie Bolden, sorry, the Honorable Charles Bolden, Dr. Grunsfeld, and Dr. Agnew. Hope I got that right this time. I was practicing. My name is VJ, and although I would love to be counted as an astronaut, unfortunately I'm not one. So I'm not one of the distinguished gentlemen here. I'm a PhD candidate in electrical and computer engineering here at Ohio State. I also have my undergraduate degree in electrical engineering. What I was hoping to talk about today was the role of STEM and innovation on the future and the future of space exploration itself. As a child, when I grew up, I used to live in Austin, Texas for a while. We used to go to the Johnson Space Center all the time, watching movies like Apollo 13. What drove me into engineering was the inventiveness of what we saw in these movies and the kind of problems that people were solving. I think having a cause to rally behind is what really brought us in America to where we are today in technological innovation. So, I'm very interested to talk about that, and NASA and the space program in the 4 hours, 55 minutes, and 23 seconds that Senator Glenn was in space, rallied an entire generation of engineers and scientists that really brought us to where we are today, or at least that's my hypothesis here. On a more direct way that Senator Glenn has helped me, interestingly, I work at the Ohio Supercomputer Center, and our supercomputer is named after Senator Glenn, so I might be the only one on stage that's logged into Glenn every day. So thank you for helping me get my research done. So I'm looking forward to some of the questions, and just honored to be here. Thank you.
Thank you to all the panel members. At this point, we're going to take some questions from the audience, and we also have people watching on NASA TV who will be sending questions via Twitter. But while you formulate a question and while some of the questions are coming in via Twitter, I'd like to take the prerogative as the moderator and just pose and put a question out there. There were really untold advances that had to be made to put people in the orbit of the Earth and to build the International Space Station. Can you talk about one or two of those incredible design innovations that have had an impact on our everyday lives on Earth?
Go ahead.
Well, if you want to talk about how we got there, Dr. Robert Goddard and then Dr. Werner von Braun, who came from Germany, were sort of the pioneers in rocketry. I'm certain as kids they dreamed of how you would enable a vehicle to reach the kinds of speeds that would be required to escape from Earth's gravitational pull. And we don't go away from gravity. It's important to understand that. You're always under the influence of gravity. But if you go fast enough, you overcome it or you neutralize it. And so the reason astronauts float is because they're going at a speed that creates a force that opposes gravity, and you end up neutrally and you float. So that's what makes it fun. Some of the challenges right now that Senator Glenn is always harping at me about getting solved are medical challenges. They are the foremost challenges for us now, things that many of them we understand. We understand bone loss, the mechanism now, a lot more than we did before. The human body deteriorates very rapidly when you go into a microgravity environment of space. So you see the aging process in a matter of days, not years. Osteoporosis, the same condition that we call osteoporosis here on Earth, occurs over days and not years. The good thing is that through new types of exercise, we're able to replace the bone mass. So whereas when John and I first flew, and especially when Senator Glenn flew, we lost bone mass and we didn't get it back because we didn't have the proper exercise regimen. Today, many of the astronauts come back and they're just as healthy as they were when they left. Your muscles atrophy. It's like being in a cast unless you exercise. So we found that exercise was critical. Loss of visual acuity. In a microgravity environment, there are pressures that we don't fully understand that seem to be causing a flattening of different areas of the retina that affect vision. So these are some of the things I would just throw out that you all are going to have to help us solve.
I comment. I think one of the things that had to be developed as we went along was a computer capacity, because hard to believe, but on Project Mercury back there, people asked me how many computers I had on board, and you may know the answer is 0. We didn't have computers on board then. We hadn't developed them. And when we worked on the big human centrifuge at Johnsville, Pennsylvania, it was controlled by a computer, but big computers were so rare in those days, they each had a name, and that was called Computer Typhoon, I believe. And at Typhoon, when something went wrong with Typhoon, the tech people had to go out in an area about the size, half the size of a basketball court, and climb up on the ladders to find the vacuum tube to make it work. And that whole computer there didn't have the capacity of, you go down for $20, you could buy a used computer now that had many, probably hundreds of times the capacity. So I think and all the control things that went on the, all the control functions were based on big computers on the ground then, but as we went along and Neil Armstrong and the people got ready to go to the moon, then that's where all this became very, very important. In that area of information flow and technology and computers, I think that was one of the most important things, because as far as straight, flat engineering went, we had the engineering principles that allowed people to design that Saturn V and all the functions. It was just a matter of all the huge amount of engineering detail to work out to make it work. But I think without the computers that developed along the way, and I think there was a lot of pressure for that development from the space program. We had computers, in other words, much earlier than we would have otherwise had. And then DARPA, Defense Advanced Research Project, had the DARPA net that resulted immediately, then almost immediately, into the internet as we know it today. So there was a progression there in that particular area.
Very interesting. Any other advances?
Well, I think it's great that we're talking about the advances of microelectronics, and the reason why they had to go micro is because you couldn't launch a computer the size of half a basketball court into space, even on a Saturn V, and that forced us to have to go to very low power, very lightweight electronics. And I think it's absolutely remarkable that just a little while ago we had a high-definition interactive video conference with the astronauts on board the International Space Station, and that was enabled by something called a charge-coupled device, an imaging sensor. And 22 years ago when the Hubble Space Telescope was launched, it had a very, very early one of those sensors, one that today, if you were to look at even a smartphone with the capability of that first sensor, you'd say it was a pretty lousy smartphone camera. But through all of our developments using and pushing imaging devices for space, we've advanced that to the point that now everybody has a high-definition camera in their phone. We have video cameras here using those sensors. And that's part of the point of it all, is as we go out into space, is to bring that space experience back to Earth and to be able to get it in the kind of detail that allows us to vicariously explore space, even if we don't get to go. And so that's been, I think, a major advance that's both enabled and been enabled by space exploration.
And I think that's a wonderful point, and that's really the point of the question, is that the impact of the NASA space program, while there were some immediate goals to get to a certain spot, to do a certain function in orbit, had huge impact on, back on Earth.
You can't tell how far these things are going to go either. I briefed just a short time ago on some of the research right here at Ohio State on, we've taken this computer stuff now, and the micro chips now that developed out of all this can be implanted in different parts of the brain to energize things that they're just in the process of trying to define now, and you, I'm sure, could give us chapter and verse on a lot of these things. But they're just fantastic, like Parkinson's and things like that, where you can energize by a tiny computer chip. Now, tiny. And that came out of all this emphasis. So one of these scientific advances leads to another, and that's been the history of our country.
So how about some questions from the audience? We have microphones on either side. We would love to hear some of the questions from you.
Or comments and suggestions. Yeah.
Harvey.
Good afternoon. It is an absolute pleasure to be here. The last time I saw Dr. Grunsfeld, he was transitioning, going supersonic on top of a big plume of flame up down there at the Cape, so that was a great launch to witness personally. As I was rereading and re-looking at some of the details of Senator Glenn's flight when he flew, I believe it was MA6, is that correct,
right,
Senator Glenn?
Yeah.
I had forgotten that MA1 blew up shortly after liftoff. MA2 was successful. MA3 blew up not too long after liftoff. Then there was MA4, MA5, and then you were on MA6. And you always seem to take it in stride and minimize the risk. But my question to you and the Honorable Charles Bolden, who rode on the shuttle a number of times, Mr. Grunsfeld, has our country become risk averse? Because, to put it bluntly, what Senator Glenn did was gutsy in the highest order of the word. And we were doing things back then. We were in a race with the Soviets, so to speak. Are we willing to make the kind of commitment it takes to do the things we need to do that, quite frankly, there is simply so much risk involved? Can we do it? Do we have the stomach to do it as Americans?
The early Atlas program, well, I might recount for you. The very first time that the NASA was going to take the 7 newly selected astronauts down to the Cape to see a missile launch. None of us had ever seen one. And they were supposed to have all the problems worked out on this particular vehicle, and it was going to be a demonstration flight for us. So we went down there. It was going to be a night launch, and we were out on a pad that was 2,000 or 3,000 feet from the launch pad. We were out on a camera pad, which was 2,000 or 3,000 feet from the launch pad. Beautiful. Drag on the airplane, on the spacecraft, at 27,000 feet, which is sort of over our head, and blew up. We looked at each other and thought, we better talk to the engineers tomorrow morning, which we did. But then they had the other flights that after that then had figured out the problem. They analyzed it. It was all instrumented very heavily. And we weren't on this thing. We didn't go on it. We went on only after we were very firmly convinced that they had worked out the problems on this thing, and it was okay. Now, I think to say that, I'm not implying that space travel is going to ever be like climbing in your automobile, turning it on, and driving downtown. I think space travel, by its very nature and the speeds that you're going and the complexity of the vehicles, you're going to have some risk. But we felt we had minimized those risks, and I think that's what everybody will try to do into the future. Charlie mentioned this balance between gravity and you can look at the centrifugal force if you want to, going around the Earth like that, like putting something on a string and swinging it around. And that pull of gravity is exactly balanced, I mean perfectly balanced. If you upset that balance just a little bit, it changes your height on the other side of the Earth dramatically by even just a few feet per second. And so it's a whole different way of going. But the thing I was building up to was the speed you're going to get to that balance is just about right at almost 17,500 miles an hour. Now that's about 18 times the normal rotational speed of the Earth at the equator. And so when you're that figures out to be almost 5 miles per second, just so you can relate to that one. So that's the kind of, and when you have that kind of speed, and you're going to have high heat of reentry when you come back, and these things are going to have some. There'll be I don't think you're ever going to have a spacecraft go up that is 100%. Of course, your automobile's not 100% either, but I think you're going to have risk in space just inherently because of the speed and complexity of the vehicles that have to be built to go there. But you want to minimize those, obviously, and that's what we tried to do back there in Project Mercury.
Since we can almost never get a risk to zero, we use a process now that they didn't want to use when John first flew called probabilistic risk assessment. And I know a lot of people are familiar with it, and it's because people misunderstood it. Probabilistic risk assessment doesn't tell you whether to do something or not. It tells you where to put your investment. We have limited funds. And I was glad to hear Serena say that she's out working with commercial providers, the industry. Stop using the term commercial. It's private industry. Whether they're publicly traded companies like Boeing or a wholly owned privately traded company, not traded like SpaceX. But it's American industry. We have to develop a trust relationship with them. When I came into the astronaut office, that trust relationship was well established. We had companies like Rockwell, Boeing, Lockheed Martin. They had stood the test of time. People like John and his cohorts had gone through the agony and ecstasy of learning how to trust them. So it was a matter of me just coming into the office. Even though they're the same companies today, Serena and her group are the first that are having an opportunity to reestablish new trust relationships, and it's because of the way we're going to do business. We're not building with them to take it over and operate it. We are building with them to use the asset that they provide, and we're going to purchase a service. That may not seem like a difference. That's a big difference because it's theirs. They control it. We have to convince them that these are the requirements we would like to meet and then make sure they meet them. So it's really requires strong oversight. But without the trust that's developed by working hand in glove, side by side, through trial and error, you don't get anywhere. We have to be willing to fail. Hear what I say, Travis? You have to be willing to fail. If you go through life and you never fail, my contention is you never tried anything worthwhile. Failure is painful sometimes. Flew my first space shuttle mission on left Earth on January 12th, 1986, returned to Earth on January 18th, 1986, and I was about as high as I could be. 10 days later, I lost 7 of my closest friends and Challenger. Let me tell you, you come down really quick. John will tell you, just trying to get to Apollo, we lost the Apollo 1 crew on the launch pad. Many people will tell you we would have never gotten to the moon had it not been for the sacrifice of the Apollo 1 crew, because it just smacks you in the face and tells you how little we know and how hard we have to work to get to do the things we do. But we're in risky business. And anything worthwhile.
Even though we're going to private industry, though, I think you're still supervising the safety aspects of this. Because there's a lot of lessons learned through this, through the past 50 years. And you don't want those to go down the drain either. If you're going to put people up there, Americans are going to go back into space on that. So all these safety things that they've learned in NASA are still applied to industry. They're not left out there just to develop their own new safety rules and so on. It shouldn't be.
So NASA, as a federally funded agency, is subject to the winds of political change, and I'm sure that we all know, over the last 20 years, all the various space shuttle replacements that have come and gone. And General Bolden, you mentioned sort of the limited funds that NASA has, and I was wondering, thinking ahead to creating an exploration program that lasts over a decade or a longer time scale, how do you do that when every 4 to 8 years you may have a new administration coming in who wants to sort of reset things?
Well, the philosophy we've taken is in cooperation with both the Congress and the President, is to go with an evolvable system. And fancy name, we just say it's a capabilities-based system. We're going to do the best we can with what we have. We're going to crawl, walk, run. So you'll see that the first heavy lift vehicle is a 70 metric ton vehicle. We have that almost now, just using pieces and parts from the, taking some nuggets from the Constellation program, some nuggets from the shuttle program, and as we get new propulsion systems, we'll put them in. The system, we have to have what we call open architecture with our design, so that as better capable systems come on board, you can plug and play, if you will. We're looking at new boosters now to take our capability up to 130, 150 metric tons. It will take advanced booster rockets. So we're starting out with the solids that we use today. Well, actually the 5-segment solid, which will be flown for the first time. And eventually we'll get to a more powerful solid that probably will be twice as powerful as what we have today. But it's going through that on an evolvable basis. But the key is planning, promising, demonstrating. If we don't demonstrate that we can do what we say we're going to do, then the nation will wander all over the place. And, John probably has the biggest challenge, because in the world of science, it doesn't come cheap. And so, there's a lot of pressure on us to perform. While we understand we're going to have failures, we have to be able to make sure that we understand it once it occurs so that we don't make the same mistake again. But I think the biggest thing is planning very well and then executing on that plan such that you deliver on time and on cost. And we're doing that. If you look at James Webb, where it is right now since the replan almost 2 years ago, every milestone that we set has been met or exceeded in terms of time to do it. Every cost milestone that we set has been met in terms of it's on cost or it cost us less. So that's the way you keep people in your corner, and that's the way you keep the support. You can't do it the way we've done business before, where you say, okay, it's going to cost this much, and then it ends up 3 times as much. Just can't do that.
We have a very interesting question coming in on Twitter, and this is for Charlie or John, either Glenn or Grunsfeld. What is your opinion on a long-term moon base? Is that a direction you could see NASA going anytime soon?
I'll let the Johns.
I may have a little different view of this than Charlie. I don't know.
Probably not.
But a permanent moon base, I think we can do an awful lot with robotics. And I think we should exhaust our robotics efforts on the moon before we really plan a lunar base. If you think about what's required to establish a lunar base and keep it there with people, how many people? 2, 10, 50, whatever it is. You have to, right now, we have to carry everything that keeps them survivable up there has to be carried back and forth. Mainly one way. So you're going to have to almost a chain, and you're going to have lunar landings one after the other to support that. Can you put something up? They say, well, you can put something up that's pressurized. It'll pressurize itself. Well, that's true. Then what do you do about all the consumables? About water? Well, you can recycle water. You can't recycle the food. But you can do all these things that you can maybe develop something in the future where you are developing some way of food production up there. But I'm not sure that it's a wise expenditure to just see if you can do something like that without some idea of what kind of research you're going to do a little with it once you get there. Because if you think about absolutely everything being established up there, that's the reason this idea I always thought that we want to go to Mars someday? Yeah, we'll go to Mars someday. And I think the former administration implied at least that they thought that could be done by going from the moon. If you want to get complicated, think about trying to put up all the things that are going to have to go on to Mars, if that's where you're going to launch from, and doing this from the moon. And somehow the idea was that you're part way to the moon, so that's a good spot to do it. But the moon is just the bare start. You haven't got it out of first gear yet going to when you land on the moon, and then you're going to go on to Mars. So I guess I favor, for the moon right now at least, a very, very robust robotic program. And we can do wondrous things with robotics. And if then we get to the point where we're going to learn more by sending people, let's send people, and maybe sometime there'll be a base on the moon. But I think to start out with that just as an objective right now is very, very expensive. You probably have run estimates on this thing, Charlie, but it's and you may have a completely different viewpoint on this. I don't know. But
I'd appreciate John's.
John, anything to add?
Maybe the idea would be to make an orbital moon base and make excursions down to the surface and use robotics controlling it from the orbit.
I think that's
the same thing around Mars.
Yeah.
Maybe those are the early steps you do in between.
Yeah. Well, I think the great thing is that there is a lot of interest in the moon. I know that's one of the things when I was 3 or 4 years old that drove me at night, looking up at the moon and thinking about that people might one day go there, but we didn't go there right away. We had steps. First we had Mercury, then we had Gemini, then we had Apollo orbital flights. Someday I'm convinced there will be a lunar colony, but it might be hundreds of years from now. I think for NASA in the near future, it's pretty much just what Senator Glenn said. There are things we can do at the moon, and I'd highly recommend that people go online to nasa.gov and look at the Grail moon cam. We have 2 spacecraft around the moon right now. They're chasing each other. They're named Ebb and Flo, named by school kids from Montana. And there's a camera looking down at the moon. We have the Lunar Reconnaissance Orbiter that's been up for quite a while, taking really wonderful pictures, surveying the moon. But it is a very barren, desolate place. It does have potential resources. But if our goal is for humans to explore beyond low Earth orbit, beyond the moon, someday to set foot on Mars, where we think there possibly could have been an independent beginnings of life, either fossil life or existing life. And if not, Mars place we might be able to sustain life without all the need for continual resupply of resources. If that's the future of humanity, then that's some place we should investigate, and NASA is working in that direction. So, a plan where we use the moon to learn only what we need to learn to then go beyond would make sense, but I think if we try and put a lot of infrastructure at the moon now, that'll only delay us going further and cost a lot of money and resources.
Something like was suggested here, though, like setting something orbiting the moon and then going down, doing something, bringing it back up again. You can do some analysis on board and so on and do all that. That may be sort of a halfway step toward that would be a substitute for a lunar base. And that's one to consider, certainly.
Do you have a question, sir?
Yes, I wanted to ask General Bolden, what is the steps that are being taken to try to improve on assembly in space, getting away from nuts and bolts?
Boy. I'm gonna defer to Dr. Grunsfeld because he is the consummate assembly repairman. John has done quite a bit of work in developing Hubble servicing missions, developing tools and trying to solve the exact problem you're talking about, where you don't need nuts and bolts and other things.
Extra vehicle.
Yeah.
So I love doing spacewalks. In fact, I love doing spacewalks more than anything else I've ever done. But with the Hubble Space Telescope, we learned how to build things and service things in space, and in fact, on virtually every spacewalk on the International Space Station, to assemble the space station, we had tools that were developed during the Hubble servicing. As you know, Administrator Bolden put Hubble up, and then I went up a couple of times and helped service it. But we also learned how not to do it. Very specialized tools, very precision interfaces, very difficult to do. In some cases, working with tiny screws. As we move forward, and the International Space Station is a good example of a step in that direction, we need to look at very modular interfaces, ones that are very easy to put things together, that allow us to build things of scale without having to have large infrastructure involved. I like to say, we should design the interfaces so easy, even a robot can do it. And to that end, we have a Robonaut, and we have a robotic refueling mission on station now to demonstrate robotics. The Canada arm on the station has relatively simple interfaces, and we're going to be using that to do demonstrations of how we might refuel satellites, how we might build satellite systems and future human spacecraft systems. But overall, and you heard it in the teleconference with the astronauts on station, we need to be thinking about building things in such a modular fashion that as astronauts or robotic systems, but astronauts go out much farther away from the Earth where we cut the umbilical, they're going to actually have to build things in space. And again, modularity will, I think, be a key to that, and commonality of systems. If we have a crew capsule and we have a crew habitat and something breaks in one, we should be able to interchange parts and not have everything just single purpose.
I would suggest a couple of methods to look into is cold welding and also materials properties of metals so that you can change the crystalline shape of the metal and expand it and use like a rivet instead of a bolt and a nut. And when you insert it, then you change its property and expand it, and it grips the thing. You don't have to do all this labor of trying to do the turning the tools and all that.
That's a great point, because in space, if you have, similar materials and you don't have an oxidation layer and you get the metals with some pressure, they'll actually bond atom to atom in the same way that, alloys. I think, my opinion is the next big revolution in both space and on Earth is going to be in alloys and materials, because we now have the ability with new machine tools, with being able to print materials, 3D printing. We can actually get down to the level where we can, layer by layer, put different atoms and build up brand new alloys. And in space, it opens a whole new option for developing types of alloys that we can't build here on Earth. And certainly, building parts in space will be part of that. And I suspect we'll be doing that on the International Space Station.
Let's take a question.
I'm an engineer, and John, I did the component test programs on the Atlas for your missions.
It worked.
The idea, that was the idea.
Thank you very much. Let's take a question from this side.
Hi, good afternoon. My name is Jillian Yersich. I'm a freshman here at Ohio State in aerospace engineering. I'm also a part of the Air Force RTC program. Ever since I was 6, I knew I wanted to be an astronaut. And Senator Glenn, I actually met you. I was 10 years old, and there was an Apollo 13 viewing, and you spoke. And right behind me, right behind me, I'll never forget, was Homer Hickam Jr., for those of you who've seen the movie October Sky, read the book, and your wife. And best company for a young space cadet. I feel that was an honor. My question for you is, and the other astronaut candidates and the Honorable Bolden, who has been there, what can I do as a young woman and a young woman in the engineering pursuit of a degree and also in the Air Force to best prepare myself to be a viable candidate to be an astronaut, because that is the one and only career option for me.
I think you ought to take that one, because I think the programs are changing, and what might have been something I would advise on back in Mercury days has changed dramatically through the years.
Absolutely, and the first piece of advice that I give, because you sound a lot like kind of where I came from, where I did my bachelor's in electrical engineering, and then I kind of made a rapid change over towards medicine. So the first thing I would say is don't be afraid of change. Okay, I set off into the engineering realm. I loved it. It's not that I didn't like it at all. Engineering teaches you how to think, teaches you how to process systems. But I was introduced into the medical world and absolutely loved it and felt that that was right for me. So the second piece of advice I would give is do what you love, no matter what. There is no one path to be an astronaut. If you talk to all the people in my class, every one of us absolutely loved what we did. So now, more importantly, science, technology, engineering, math, that's where we need help right now at NASA. We need help designing new systems, building the Orion, MPCV, working together with our partners in industry as well. So the other thing is, stay focused, stay true to your goal. If I had $1 for every time somebody told me, do you know what the odds are? Do you know how hard this is going to be? Man, I'd be a pretty rich woman by now. So don't listen to any of that. Be around people who are going to support you and love you and tell you that you're going to do it and that you're going to make it. Because you have to believe in yourself. You're going to have tons of people coming from the outside telling you that it's too difficult this day and age. They'll tell you what the % chance is. So stay true to your goal. Stay focused. That's the piece of advice I first got from an old flight surgeon, Dr. Phil Stepaniak, when he knew that I was interested in becoming an astronaut. Stay focused.
And I just would like to say, I actually had a personal friend in elementary school whose aunt was Dr. Laurel Clark on the Columbia mission. And I just want to say what an honor it is to be able to go forth and pursue my dream in honor of her. So,
thank you.
Thank you. Please state your name.
Hi, my name is Ingrid Loesch, and I'm a biosystems engineering major undergraduate. My question is, the team we spoke with up in space, they mentioned jokingly that there was a need to address the plumbing problems. And I wonder, what is
do on this.
It's easier to just say Charlotte.
But there are 13 grand challenges that NASA has put out, and I know one of them is on renewable energy. Another one does have to do with biosciences. So that's kind of my thought on it. And I know that there are a lot of people that are working on that. And when you kind of look at the challenges that society itself has, alternative energy is one of the large challenges. And I know that NASA, when I looked at the grand challenges, almost 2 or 3 of them related directly to alternative energy. And it's my understanding there's considerable funding associated with these challenges and to help researchers in universities or in different companies to bring this technology out to the public.
Is there any research into microbial fuel cells?
Microbial fuel cells.
I know I had at some point worked with micro fuel cells. I'm sure microbial fuel cells are at a much smaller scale.
But I know we're looking at different virulence patterns of different microbes. That's kind of different from what you're asking. One thing that does pertain to what you're asking, though, there was a project that was entitled IV-Gen. This is a system that looked at taking your basic water source, potable water on board ISS, and turning it into highly sterile water, the type of water that if you were in the emergency room or a hospital and needed IV fluids, it would be suitable enough to put in your bloodstream and it wouldn't make you sick. So using different filtration systems, it was a very successful experiment. So you talk about bringing that back down to earth on the battlefield for our soldiers. We can't bring tons and tons of liters of IV fluid out to our soldiers who have experienced a traumatic injury in the battlefield. But if you had a small, portable, lightweight system that could quickly generate sterile IV fluid, such as we tested on board the ISS, that's useful. So not only for our long-duration missions, but for our soldiers here on the ground. So that is one technology we're looking at.
I would offer one, I know John has something. I would offer one thought. The other John, little John.
Not me.
One of the things that we have asked our team to start thinking about is, as we look at the NASA of the future, we have to be relevant. And so if we are to be relevant, we should think, first of all, what problem would I like to solve here on Earth? Clean water, getting rid of pathogens and other things that kill kids, that limit the life expectancy of a child. How can I attack those problems? And then what advantage does it give me to be able to experiment with that in space? Because space presents an incredible advantage. As John says all the time, the International Space Station is the most remarkable laboratory because you take gravity away. And so, molecules and atoms and everything goes to its natural place. And you can look at the way that nature would have done it, absent gravity. You can pick genes out. You can do a lot of things a lot easier in a microgravity environment than you can down here. So what I want our folk to do is solve problems here on Earth. Do things that are relevant to all of us. And we'll take care of astronauts that way. They don't run into, we need to solve normal kinds of problems that affect people here on Earth.
So I'll just add one little bit to that, which you've heard in all of these responses, and that on the space shuttle wasn't such a big deal because, well, in the plumbing, we could just bring it all back and clean it out when we got back on Earth, and we could bring up food, and when what we ate, and bring back a bunch of trash. But as we moved to the International Space Station, 6-month expeditions, looking at sustaining crews for longer, all with the point of eventually sending crews further out. We've talked about systems engineering for the mechanical hardware. We haven't talked about systems engineering, including the human and the life support. And so that's what we're getting to on the International Space Station with recycling the water, turning the water into breathable air. We dump the hydrogen overboard. Well, maybe we can keep the hydrogen, turn it into fuel, use it for plants, adding it with organic carbon that comes from the humans. All of these closed cycles, we have to get to that point before we can really do sustained long-term exploration. And you may say, well, that's fine. How does that relate back to planet Earth? And I would argue that on planet Earth, we're treating the Earth sort of the same way. We mine the Earth, we put our pollution in the air, We grow food, we put fertilizer in, which eventually makes its way to the ocean. You know, we've not yet on planet Earth gotten to the systems engineering of planet Earth with humans in the loop. And that's something that NASA has satellites that are taking data to see what effect we are doing, to try and measure, you know, is what we're doing good, bad, otherwise. As we make changes, as we change our fertilization patterns, do we decrease the amount that goes into our water supplies and out into our oceans that affects fisheries? And we can see that with ocean color, for instance. And so we're starting to do that systems engineering in space. And one of the things that NASA can contribute is that system engineering with humans, with life in the loop back here on planet Earth.
So let's take a question from this side.
Well, good afternoon. I'm Avtan Srivastav. I'm a junior. Actually, I'm not an engineering major. I'm a finance student at the Fisher College of Business. Okay. And I have been really interested in NASA's program since I was a child. I am really honored to ask some questions to the panel of NASA administrators and NASA astronauts as the Honorable Charles Bolden and John Glenn. I have some questions regarding NASA in reference to a more global level. So my first question to you is, how do you think the immigration policies of the U.S. might impact NASA's employment and NASA's work with other countries? And my second question to you is, how do you think that the research work NASA does and the benefits of NASA, how much time will it take for the developing countries to reap those benefits?
Let me try the second one first.
Okay.
We have a program called Severe. It's my favorite because it's a program that we work cooperatively with the U.S. Agency for International Development. The Earth orbiting satellites that John talked about that look at the atmosphere, the oceans, soil, everything. We provide 30 years worth of archive data plus real-time data that's coming from these satellites to 3 different locations around the world. One is in Panama that services Central and South America. One is in Nairobi, Kenya that services about 15 East African countries, and another one we just opened last year in Kathmandu, Nepal that services about 8 countries around the Himalayas. We're helping people build drought and flood models. We're helping them understand how do you plan your crop rotation, because you're looking at, you know, hyperspectral imagery, big word, okay? It just means you can see things about Earth. Don't worry about it. Travis is listening. But hyperspectral imagery, big word, and I don't know exactly what it means, but it allows us to look at the elemental structure of things from way away, just looking through cameras that are looking at different wavelengths. We can tell things about our Earth and our atmosphere today that we never knew before, and we can use them to help people in developing countries make life better. Serena mentioned fresh water. Millions of children die every day, some of them in America, because they don't have clean drinking water. They die from waterborne pathogens. If we can get, you know, a water filtration system similar to what we use on the International Space Station into a village somewhere in a, you know, some remote jungle, or even in somewhere in my home state of South Carolina, you know, you're talking about saving lives. In terms of immigration policy, I'm not going to go there, but we thrive on being able to. I'm a 34-year veteran of the Marine Corps. John's 20-some-odd years. Both of us learned that you advance when you engage people. You know, the more time you spend with people you do not know and you do not understand, and help them understand your culture and you theirs, the better off we're all going to be. You used the description the other day about, you know, you don't fight people that you're working with and trying to pursue a common goal. The more young men and women we can bring into the United States to benefit from our educational system, to meet our kids, but also to have our kids meet them and understand who and what they are, the better. And that's always been a hallmark of NASA is international collaboration. 15 nations in the European Space Agency. That's just one component of the International Space Station. That has been operating for more than 11 years, 24 hours a day, 7 days a week, 365 days a year, without absence of occupants. An American has been in space, and hopefully everybody in this auditorium knows this. There has not been a day in the last 11 years that we have not had at least one American orbiting Earth aboard the International Space Station. That is really really, really important for all of us to know. And as far as I'm concerned, hopefully there will never be another time in the lifetime of any of us, our children, grandchildren, great-grandchildren, when there will be a day past that there's not an American orbiting Earth, you know, from some vantage point, hopefully from much farther out than station. So don't know whether that answered your question or not.
Yes.
Your question about working together on things, there's a little story I might tell here. This is a little off, but I think it makes a point. When I was getting ready to go on the orbital flight, I got looking at the flight plan one day in the map, and I was going to go one of the orbits. I was going to go over the Southwest Africa and Namibia, the Kalahari Desert. Another area was going to be in the outback in Australia. Another was going to be up across the length of Papua New Guinea. All those are places that had Aborigines there still. Some we just getting in touch with them at that time. And so I thought, you know, we were concerned about would I have to make an emergency reentry, and I got thinking, if I come down in one of those places, and here's some people on the ground, the Abos, the Aborigines there, and you have and they hear a sonic boom, kerboom, and they look up, and here comes a little black speck down, and then a big chute comes out of that thing, and this thing comes down the clearing, and there it is, and the side blows off of this thing, and out steps this thing in the silver suit. I thought I was going to be elected God or king or be dead pretty quick. So I thought it was worth enough effort anyway to put a little message down. Me, friend, take me to your leader. Big reward, all this sort of thing. And have this translated into some of the languages that might be useful in those areas there, some of the more primitive languages in the world. And it happened that when we had these translated by some of the expert linguists, and I had it in a form that I could use, the word for stranger and the word for enemy was the same word. You got to think about that a little bit. In other words, if you don't know somebody, boy, they're an enemy. And the closer you work together, the more you find. When I was in Project Mercury 50 years ago, here we are now, 50 years later. Back then it was the Cold War. The whole Russian program was absolutely secret. Now we have people up there doing flight command work, working with all of the people up there. I don't know how many Russians have been on the International Space Station, but it's a batch. And they work very closely back and forth at Houston. Our people have a permanent facility over at Star City, and 15 nations involved with this whole, 15 other nations beside us involved with this whole thing. I think it's been one of the biggest efforts toward peaceful cooperation that the world has ever known. And I hope we continue that, because I believe, just as that little old message was back then, the word for stranger and enemy to be in the same word. Let's get to know people around the world.
Very quickly.
Sure. A quick. So when we're looking at STEM and kind of to address your first question of international, students working with NASA, I know that there is a report that was written called "Rising Above the Gathering Storm." I believe this was a 2007 publication where they're really looking at what can help get the U.S. back on track with STEM education in particular. And the STEM fields are about 30 different fields that fall under STEM fields. But one of the recommendations that was given in keeping the best talent in America is to look at ways that you can work on immigration policy to keep some of the smartest people in the world here. So that might be a good publication to take a look at.
Well, thank you so much.
We are out of time at this point, and I'd like to really thank the panel, each member of the panel, for their impressive contributions.